Most AC meters are calibrated to read not the maximum value of the current or voltage, but the root mean square value. That is the square root of the average value of the square of the current or voltage. Because I squared, the average of I2 is never zero, even when the average of I itself is zero. So even though the average of that obviously is zero, but I squared won't be, you can see, because it's all on the positive side. Also, root mean square values of voltage and current are useful in relationships of power in AC circuits. So in this figure, it shows the graph of a sinusoidal varying current, that's that one there, and its square value, which is that one there. If I equals I sine Wt, which we've put here, then I squared equals I squared sine Twt, and we can just use a compound angle formula, take that sine squared Wt and just use the compound angle, which is 1 minus cosine 2 Wt, half, and just expand that out, and we get I squared equals a half I squared minus a half I squared cosine 2 Wt. The average of that, because it's another sinusoidal function, it's going to go above and below the line, then that average is going to go to zero. So the average of I squared is always going to be a half I squared, this term here. If we take the square root of that quantity, then that gives us the root mean square value of I simply means the square root of this. In the same way, the root mean square value of a sinusoidal voltage is VRMS over V over root 2. Have exactly the same argument. Can define a voltage as little v equals capital V sine Wt. We're going to get the same relationship. We can define this new terminology, this root mean square, with voltages and currents, and it's the same proportionality, 1 over root 2. Voltage and currents in power distribution systems are always referred to in terms of their root mean square values. Thus, when we speak of our household power supply as 240 volts AC, we mean that the root mean square value is 240 volts. So the maximum voltage for a household 240 is in fact 339, so it's going to have peaks. The peaks here are going to be 339, although the average, the root mean square value, is measured as 240. So all the voltage current relationships developed up until now have been stated in terms of their amplitudes, which was these values here, maximum values of voltage and current, but they remain valid when RMS values are used. In each case, the difference is simply a multiplication factor. You only have to remember 1 over root squared, how to go from a root mean squares back to the maximum amplitude value here. You just simply multiply it by 1 over root 2. So that covers that. I just want to quickly go through that because that will come up quite a bit when you're working out problems.